Hi, everyone. Welcome to our webinar today. My name is Jack Kuhr, and I'm the research director at Payload. Today's webinar will be on unlocking agile engineering in the space industry with Prewitt Ridge. Today's guest, we have Steve Massey, York Zhang, and Gary Redman. I think what is best right now, we have three Prewitt Ridge people on the call. So I think what's best is if we go around in a circle. We do very brief introductions on each other, and then I know Steve, who's the CEO and founder, is going to present a little bit as well. So, Gary, why don't we start with you on an intro on yourself?
Hey, thanks, Jack. Gary Redman. I do business development and sales with the company. I've been with the company for about a year. My background is in defense and aerospace, specifically hardware. I've got a background in systems engineering, and so that's what really brought me onto the team, is my ability to kind of help integrate systems engineering with developmental engineers and design engineers as well.
Thank you. And York?
Hi, my name is York. I'm a hardware development engineer with a specialty in propulsion and systems engineering. I work primarily with startups and had a few stints with NASA Goddard and Blue Origin, and I was brought on to the BD and sales team at Prewitt Ridge to help them bring requirements management software to the whole world.
Awesome. Hey, I'm Steve Massey, CEO and co-founder of Prewitt Ridge. I started this company 4.5 years ago with my co-founder Zeke. Before that, I was at SpaceX for 6 years. I saw most of the first Falcon 9s up through Heavy, and then at Slingshot Aerospace as an early engineer, working on edge compute, real-time AI analytics for the defense industry. Pulled this company together and built it to really serve a growing problem we've seen in the industry, which is not only agile and accessible requirements management, but also just broader systems engineering challenges that we've experienced firsthand.
Great, thank you. And Steve, I know you have a presentation, which I think it could help contextualize what we're going to talk about today and give an intro on Prewitt Ridge. So if you want to kick off a screen sharing.
Yeah, absolutely. Yeah, so just as a background of our company, Prewitt Ridge, we built a product called Verve. The impetus to build this really came out of some of the challenges that me and my co-founder experienced, particularly mission management back at SpaceX, and then saw again at Slingshot Aerospace working with other folks. Basically, we had to collect information from a variety of different customers and then really put it into our own tooling and then drop it into something like a SharePoint and then share it with a bunch of other engineers inside of the platform, inside of our organization. We budgeted 6 months to do that work, really. Most of that time was spent tracking down the different engineers, getting their approval to continue the work they were starting, and then to just go about the process of talking to trajectory, talking to loads, so on and so forth, to get that cohesive mission design review all together. What we've conceptualized and we've built over the past 4.5 years is effectively a DevOps for engineering platform that allows us to bring in disparate engineering data sources, whether it's an analysis system, some sort of model, and link them all together with that requirements as that messy human layer so that we can make sure that everything is in alignment when we go to actually build out our system and build out a complex engineering project. We do this in a rather unique way. We sit in between a number of different tools. We act as the authoritative source of truth. Requirements management folks interact with our tool, but subject matter experts themselves will work in their preferred tool of choice, whether it's analysis or design. And we sit as data fabric and support both operations. This allows everyone to come together at the end and ensure we are building the correct system in some way. And just get that confidence for those mission critical launches, design decisions, and beyond. So not just launch, but also aviation, autonomous systems, automotive, beyond from there as well. Really anything in a highly regulated, high impact environment.
Great, thank you.
Yeah, just to set the stage a little bit, we really do conceptualize there are 3 users for this type of platform for a DevOps for hardware system. It's your systems engineer, your subject matter expert, or your individual contributor, and then your external stakeholder. It's really what those are the 3 personas that really need to be involved in some sort of a large scale design or even acquisitions process all the way end to end. And so that's really how I wanted to frame the conversation today. Is how do those users really participate in such a system? Who are those users as well? And then how can we best continue to serve them going forward?
Great, thank you.
And then just the three approaches we've been taking with approaching this is a mixture of data repositories, design reviews, actions, and automation. So with that, I can pause here and pass it back to you, Jack.
Yeah, great. And just for the audience, there is a Q&A chat. If you ever have a question, we like for this to be as engaging as possible, and we'll try to answer questions real time. But appreciate that intro on Prewitt. Maybe let's try to boil down what the problem is that Prewitt is trying to solve. Maybe York, I'll throw this to you first. If you were to boil down to one or two problems that Prewitt and Verve is looking to solve for your customers, and maybe from considering your prior experience and the problems you've had as an engineer, what would you say those couple problems in a concise way are?
Yeah, so there's a couple things. I would say that systems engineers spend a lot of time herding the cats, right? They're dealing with a large amount of information that's split between different teams, different hardware, and different disciplines. And so when you spend most of your time giving updates on whether your requirements have changed, you aren't actually tasked with doing what you were hired for, which is to specifically understand the integration pain points when you're actually building these complex hardwares. And so if you're able to provide these updates without actually having to, talk to a group of people in meetings after meetings, it allows you to go and do the things that are much more important, which is to actually solve the problem. And the second thing that we want to do is a lot of the work that these systems engineers do is presenting that verification evidence to these internal and external stakeholders. And if they spend a lot of their time working within the document, a lot of it is just something that can be automated. So we want to free up their ability to go and actually do the thing, and to enable them to work with the most accessible data so that everyone who works with them is also on the same page.
Got it. So a lot of it is timeliness and freeing up time for system engineers and for keeping things on track, keeping missions on track. And how about the accuracy? You touched on it, I think, at the very end, but how about the accuracy part of it, Gary? Maybe this one's for you. What is the problem with kind of accuracy and just getting things right and getting things organized that you see with Prewitt customers or generally in the aerospace industry?
I would say it's more a collaboration piece between both the design engineers and their managers. So one of my last jobs in the Navy, for example, was I managed a medium to small size aircraft test team. And one of the problems I dealt with was the manager was making the appropriate decisions for that test team based on the data that the engineers were gathering. And I think, it was a lot of times it was hard to just look at PDFs or a test document and to really understand holistically the problem that we were dealing with within the test team. And I couldn't I needed to make decisions off of that data, and having a place that I could go and just look at data in a conceptually in a manner that is easy to ingest and make a decision based off that was really some of the major pain points that I had. And I think that's, one of my passions within the organization is trying to solve that piece between the business and the technical side of the organization so that the decision makers can make a better decision based on the data they're receiving from design engineers.
Got it. And Steve, it's interesting your background coming from SpaceX, where you would assume that a lot of these collaboration kinks would have been solved, as they're known as to be the most efficient and flat organization in many ways. But can you touch upon your experience at SpaceX and why collaboration was still an issue?
Yeah, I think it had more to do with the disparate engineering groups in particular, and coming from an organization that really presented itself as having that mission level systems engineering approach. in an organization that famously was adopting a more agile software approach for everything. So there's no reason why they can't both be in alignment. One of the things we just really wish one of the things we identified was that a lot of the slowdown was a data problem in terms of pulling together mission analyses or doing any sort of other complex interdisciplinary work where the data needed to be correct going in from one discipline into another discipline into another discipline. And there was effort spent shaping that data and working on that information. Then, since that was a manual effort to actually go in and do the work, that turned into a human scheduling effort in terms of bringing that work together as well. So what really highlighted it for me was not necessarily the really awesome opportunities to build out new ways of approaching that internally there, but the parallels I could draw when I later went to Slingshot Aerospace and I was interacting with the primes. They had similar issues. We just used different language in the defense industry, and it was only after I saw those two parallels together, really convinced that there isn't really a system on the market today when we started to go out and build that out, and it just seemed like the right thing to do for not only new space, not only aerospace, not only defense, but beyond into automotive autonomous systems, medical devices, and so on.
Got it. So let's try to bring this into kind of real world examples. Like, could you give an example? It could be a theoretical example at SpaceX or at Slingshot where maybe you had how it was before, what were the challenges were before. Maybe it was you had a system engineer who's doing something for 2 weeks and then would have to pass it on only after the fact when it was done to another person. Could you just give kind of a real example of how that could slow down workflow? And also maybe, for our audience, we can just define what a system engineer does as well, and other engineers as well, just to contextualize even more.
Yeah, definitely. And that's kind of why we went back and thought through who are the real users of such a platform, who are the actual stakeholders here that are invested in a system actually working, and try to distill it as low as possible. I know as many large organizations, there's many different titles depending on what you do and what department you're in and what your engineering background is. But fundamentally, we try to boil it down to 3 specific users. You got a systems engineer. You could even imperfectly relate them to a responsible engineer, someone who's responsible for a set of work getting done that has to go cross-functional across a few different subject matter experts, right? You get a more agile or smaller organization, you could merge that with an engineering project manager in some way as well. A large organization, these may all be different people, but they're similar enough personas that they really care most about that cross-functional identification of, okay, I have to work with a mechanical engineer and an electrical engineer, and you get the software on the chip, on the board, and the box on the vehicle. And how do we make sure we are making sure the software is built to the specs of the chip? The chip will actually match the footprint of the board. The board itself will fit inside the box, and the box's bolt pattern matches to the vehicle itself. Relatively simplistic example, but if you have 10,000 people at a company, that scale, that problem of scale, starts to fall apart, and you start to miss things at that point. And so that systems engineer or that responsible engineer is often responsible for that upper level of being able to really understand, about sharing this, that big picture. Then you have the subject matter expert, right? That is that engineer who they are the ones either developing the software, they are the ones that are doing the mechanical design, they're running the fluids analysis, and they have an input, they work on something, they do the engineering work, and they produce the output that plugs into the larger system, and they really want to focus on what their specific role is. And so that engineer itself, they're the ones that are going in and doing that development work to support the larger system that then gets integrated into everything else. We have a third party that's important to highlight. This is an external stakeholder. This could be someone at an external party, an external organization. It could be the next department over that eventually has to consume the product that you're building. It could be the part of the fuselage that you're software on a chip and a board and a box gets bolted to, or it could be an end customer. It could be your government customer going through a digital acquisition cycle in some way. It could be a vendor, right? So you have an external stakeholder that needs to have some sort of influence or approval or insight into what the two other engineers are doing here, and then be able to actually develop that opinion and that feedback so that we can actually end up building the correct system. So then going back to the earlier question of how would you actually be able to pull this together, I think one thing that I've in the chat here, so we poured real world tests of the software. Absolutely, we have two customers that ran a joint design review through the platform, one offering a spacecraft bus, and the other one building a payload that flies on that. And they were able to go through that flow and that process to get to confidence with engineers who are either the systems engineering manager on one end, an external stakeholder, but separately a systems engineer on the other end, and provide that flow in the process there.
Great. And we have another, thank you. And just a reminder, if you have any questions, you can put in the chat. We have another question in the chat on, do you incorporate quality assurance software tools into your overall architecture?
Right, so our system can plug into external tools beyond the ones we built native integrations for. A lot of these quality assurance tools are built out, particularly SAP built custom to what's going on inside of the enterprise. And so that's definitely something we're comfortable and capable of building against because of the sensibility of the platform beyond the existing integrations.
Great, thank you. And so who are your customers here in general? Are they space startups? You mentioned that you serve a variety of different fields, including other vehicles, but generally are your customers startups? Are they space startups? Are they primes? Are they government contracts? Who do you serve?
Yeah, it's been a mix. So definitely SMBs on the space side. I think that's partially to do with what our background and the community we came out of. We've also been seeing success on the defense side as well. I think there's a strong pull for this type of technology, and the legacy tools, particularly in the defense industry, have not necessarily been really cutting it. We've also had a number of government engagements. Obviously, every small business goes through the super cycle. We've also transitioned other work beyond that into other contracts with government organizations, platforms.
Got it. Yeah, and York, maybe on a similar vein of questioning, how do customers differ from startups to more traditional primes and legacy aerospace versus government? Like, what are the needs? Are you addressing this similar needs, or do they have different wants and asks from Prewitt?
Yeah, I would say that Prewitt is first and foremost a dual-use company servicing both commercial, government, and defense. The main strategies when it comes to the go-to-market strategy is for commercial. You generally have, at least within the new space environment, pretty flat organization. It's pretty easy to figure out who has the decision-making power, who the end users might be, and who you would need to reach out to during the sales process. When it comes to defense, we've recognized that there's essentially three layers. You have this triangle, where at the very top you have the people who have the authority to purchase this new software or hardware. In the middle, you have the people who connect the top to the bottom, so these might be bureaucrats or other operators. And then at the very bottom, you have the people who are actually in the field, who are actually going to be deploying these different systems. And so when it comes to defense, you have to recognize that it requires long durations of multiple touch points at each level. Whereas with commercial, you generally just have to go through one sales cycle to find this person, and they are able to make that decision for you. And so we recognize that there's different strategies for different people, and sometimes it's one and the same, but oftentimes it's going to require multiple touch points.
Yeah.
Beyond that, the SMB markets, a lot of them have one or two smaller projects. It's easier to just really engage on that. Like the company and the project layer are almost synonymous with each other. Large organization, They have hundreds, thousands of projects going on. And so if you bring it, you can sell into that stakeholder, get pulled into a project on a project basis and start to grow from there. Very different than going in where what the company is actually building and the company itself being the same thing. So it ends up being an interesting opportunity to deal with a number of different stakeholders and support a number of different projects within an organization.
Yeah.
And the other thing,
go ahead. Go ahead, York.
The other thing I want to point out is there's a certain risk appetite associated with startups, right? If they do the tried and true method of, say, traditional verification and validation, something like environmental testing, which they may not need for their spacecraft, will actually bankrupt them because of how long it takes to do that type of testing. And so there's this appetite to try new software that we can really lean into as another startup, because we recognize that time is money, especially for startups. Like, money either matters. It's money. Money is either everything or it is just something that you need, right? It either matters or it doesn't. And so we recognize that the defense side is much more cautious when it comes to acquiring new capabilities, especially because you have operators who are actually in the field, and it becomes very much life or death. And so there's a bit of a cautious optimism with the defense side, which is not to say that the commercial side is like, just buying willy-nilly, but there is a sort of appreciation for genuine products that work. And so the last bit I'll say is we've seen the defense side really accept the new space mentality of trying to move quickly. And we see that with, Defense Innovation Unit. We see that with the SDA, Space Force. They all recognize that the way that we can approach hardware is fundamentally different from how we do with software. But having both of those together is really the winning solution here.
Nice. And Gary, you worked in the Navy, right? You were was it a pilot in the Navy?
Yes.
What was your experience in agile and fast moving decision making when it comes to enterprise?
So I think it was not, I think it was not a very agile process because you're solving a different problem, right? Like, you're trying to build a system that's going to withstand and last for 40 to 50 years. So maintainability and survivability is really the key aspect of what you're looking at either a defense prime, defense in general, versus on the startup side. You really are solving a different problem. If you walk into a startup aerospace company, the problem is really around risk. If you've got one prototype, you're really trying to get to that first flight, and the risk versus reward of when you're going to take that flight is really where the dollars and cents are, right? You're not going to get dollars from investors until you take that first flight and you see proof of concept. Whereas from a major defense prime or a military aspect of it, the question is like, the capability versus what is really achievable in the life cycle of products. So when I look at our product from a defense perspective, I'm looking at how it affects really all the external stakeholders, right? The life cycle of it. There's other things to keep in mind other than just the product itself. It's the maintainability of that hardware, whether it's cybersecurity, whether it's maintenance professionals. So when you start looking at the upstream and downstream requirements, you can really holistically think about those things. Because if you look right now if you look in the news between problems Boeing is having with the KC-46, the V-22, and all of these other pieces of hardware, it all really stems back to system engineering issues and not thinking about the other elements that are included in that environment that system is going to have to operate in. So using a tool like ours helps you at least think about those things earlier, so we're not building these things in a vacuum. I feel like, especially in defense, a lot of times these things are built in a vacuum without thought of the external systems that need to really support the specific hardware you're building, if that makes sense.
Yeah. Can we double click into that actually and talk about Boeing's problems? And I read all the headlines on it and see it, but you guys as engineer folks and people who are experts in management and organization, what can you attribute some of the 737 MAX issues to? Just poor collaboration and poor systems and quality. Like, what do you attribute all the issues to?
I'll let you two gents talk first, and then I'll my look. I have an opinion on things, but I'll let these two gentlemen share first and go from there.
I mean, it's hard because it's you've been working on that and stale data. You could learn from your analysis cycle that you're not going to be able to close the design trades because of the mass of the engines, but you're too far down into the business cycle, right? This all has to do with time. And so if you're able to get to that understanding that there's a failure mode sooner, like you're front loading a lot of that work, right? We see our product as being at the very earliest stages of design and getting involved as soon as possible. Sell as a requirements management tool. We plug into analyses and design, and then we start to work for the folks beyond that to go into the manufacturing side and beyond. So we're focusing on the design layer at that stage. If there's a problem with individuals not following work instructions, I pull outside of scope of our platform here. Although you might have discovered a problem with the load system or something that came out of your analysis at that end there. If you have a more fundamental problem with the aerodynamics of the system, though, you'll be able to track all those runs down faster and be able to trace them to the actual decisions made when you deviated from this specific engineering value. Because again, platform at its core, we're taking requirements management, we are elevating the actual engineering values in them that are being used inside of a system, and then placing them directly into the tools the engineers are doing day-to-day work. So that might be able to get you to a faster system, to confidence in the system sooner, and then that full traceability up and down through that decision-making process.
Yeah. Well, it really goes to show you that the cost of failure here is legit. Yeah. And there's obviously a million different requirements and things that people need to keep track of, but it's a real balance between that cost of failure, getting things right, and also speed. We have a couple questions in the chat that we can get to now. One is on Verve's value prop compared to other model-based engineering system tools.
Yeah, definitely. And I think it goes back to one of those explicit pillars that we care about when approaching this DevOps for hardware approach. Like really becoming that, what does it mean to be a data repository of engineering information, right? What does that actually mean? It's not just a collection of values that are referenced elsewhere. It's also not just flat requirements that are described and traced back up. It's a little more nuanced than that. You can't just jump in and just reference a series of documents, right? And you can't, you also don't want to train up an entire organization who is focused on building model representations of the systems that are being built. We see this with presentations given every year at the NDIA conference about what is the delay in adopting digital engineering practices. If you think about this from an acquisitions perspective, the contract might mandate a digital delivery, but the reality we've been seeing on the ground for the last decade and a half has been the engineering work is being done according to more traditional waterfall methods. There might be some instances of agile collaboration inside of a specific team, but the engineers end up doing the work in the traditional method and then developing the model after the fact and then providing it to the contracting authority. We're starting to get a little bit better with that, but one of the things you really need to get to in order to build out those models in conjunction with the rest of the work is understanding that I'm doing work inside of this engineering tool. I need to consume these values. I need to consume this information here. I could pull it in, create a mapping against like this occurred in this file. I'm using it in SolidWorks. I'm using an NX at this state. I can then map that to Team Center, this particular point in the bill of materials, and then I can reference that all the way back up. And lowering the friction of that happening is a critical part of that. So you don't make it a data cleanup activity at the end. It just happens to be developed as you're doing the work. And so we're taking the lessons learned of, well, what did we do at SpaceX when we just had to go and build a system and then certify the system and then generate the engineering and system engineering documents to prove to our customers that they will safely ride to orbit. And then looking at the last 20 years of model-based engineering and thinking about, okay, we've learned a lot of really interesting techniques that have gotten us, multiple additional landings on Mars, and it's giving us a lot of really exciting, developments in the defense space. But looking at like where those friction points were, in my opinion, a lot of it has to do with the difficulty in creating the models in the first place. So if you can use a computer to help support that with that model development cycle, while the engineers are actually doing their day-to-day work, then you start to actually enable a lot of that support. And if you can offer value on top of that in terms of supporting a design review cycle that allows people to jump in and then do something a little bit outside the scope of the standard 6, 12, 18 month design review cycle, you've accelerated it even more. So it's about taking this all the way back to first principles of why do you even want the model-based engineering in the first place? It's not to generate diagrams to give to the contracting officer. It's actually to provide, to like reap the value of having these systems digitized in the first place. That was a really good question. I don't know if that was a follow-up there. So
Yeah, no, that's there. Yeah, we have another question in the chat with regards to integrating the software within a large organization. We talked about startups having more of a risk appetite and larger organizations having a lower risk appetite. How have you seen that integration with larger organizations that have done something a certain way for 15 years? What are the challenges that Prewitt has come across, and just walk us through that process?
Yeah, honestly, there's a frustration with legacy toolings, end to end, right? Going back to that point where we're making models after the fact. Like, it's not the point of model-based engineering, right? So you're supposed to be able to make the models at a time and have them provide value and influence what you're doing. And so you actually see at the major primes, like advocates at the highest level, like advocating for their digital transformation strategy of pulling in, not only the legacy vendors, but also the new vendors as well, to try and understand how can we do what the new space folks are doing, and how do we get there faster, right? And some of that is culture, but they want to change, they want to learn, they want to build new things, and that we pull the things they need in their culture, a lot of cybersecurity, a lot of certification and buy-off controls, and understanding who is approving what. That can add a little bit of friction, but not the whole friction of going in and building full models to give to someone at the other end, unless you really have to in order to actually build that out. So we're noticing the larger companies are being more and more receptive to this, and they're excited, and there's it's an exciting opportunity for us to really go and push the needle super forward at the SMB level, and then bring a lot of that what we're learning up into the larger enterprise level. And then the SMB level ends up benefiting from a lot of the cybersecurity, and the buy-off approvals and everything we need at the top level to really support that, to really build a stronger system overall.
And we also see Siemens, for example. They've been around for a long time. They're one of the primary providers of their CAD software. But if you look at the other features and products and services they have within their portfolio, you can recognize that it wasn't born within Siemens. They were either acquisitions or, they just somehow managed to acquire the IP. And we recognize that the value for customers isn't that when you buy an item, you get 50 additional ones. Like, you're very cognizant of what you're paying for, and that's the thing that you want. And so all these extra bells and whistles are sort of like a copium of sorts, where, if you get this main product, which is our primary source of revenue, you get all these other things. Whereas if we just offer a single point of value that directly alleviates the pain points of systems engineering and, the commercial and defense side, then that's a much cleaner proposition to provide. And so we recognize that, down the line, there might be these type of acquisitions that are happening, but it's not necessarily the strategy for staying relevant. It's more of just something to do to survive, as opposed to thrive in this changing environment.
Well, to put that in context, a lot of the larger companies are offering a data fabric tool that it really just encourages lock-in within the platform. Going external, regardless of where you end up with, that forces a stronger ecosystem, right? Because we adhere to the open standards, plug into the different systems accordingly. You can mix and match from the different vendors, whatever ends up suiting your system the best. To kind of re-summarize what you're saying.
Yeah. Well, I would imagine a lot of the hesitancy comes from just the immense amount of regulatory burden and regulatory oversight that A&D has. And maybe Gary, as could be a question for you. How does Verve work within regulatory bounds, both in like privacy and security of data, and also within a system engineer's workflow, they're going to have to work within their own regulatory bounds. So let's talk about regulatory bounds for a second.
I'll hit the cultural part of that, and then I'll let Steve take the technical aspect of that question. From a cultural aspect, I think I've been talking to both big aerospace and defense about digital engineering for the past year, and I think it comes back to ownership of the data. Like there is some skepticism, but of machine learning and AI as we go into this transition of digital engineering. Everyone knows it has to happen, right? Like we have to transition the documents we have, the knowledge we have from old school paper documents and PDFs to a digital world to make that information better conceptualized. But I think from a certification standpoint, you really have to get buy-in as well from the stakeholders that own said certification, whether it's the FAA, the FCC, other entities involved have to be on board with that as well. And I think the FAA and other organizations are starting to have those conversations. They realize this is a huge problem. They're understaffed, and the only way to solve these issues a lot of times is with software. So it's really getting all the certification stakeholders to the table as well and deciding, okay, like we're going to accept this and we're going to try to understand digital engineering and how we can use these digital products to make our life, not take anyone's job, but to make our life better overall and give us the ability to make better decisions while utilizing the software, if that makes sense.
Yeah, I mean, it's one thing we've noticed is I think Army and Air Force probably furthest ahead on this. They have their digital material management consortium they're building. We're in the workshops. We're seeing what they want, what they're pushing for, and this maps against the things that I've been seeing at the conferences for the past half a decade to a decade of wanting an integrated digital acquisitions process. Right? It's very different than printing out the documents and delivering the procedurals. I did that when working with customers towards our launches. Right, the end package oftentimes. Granted, this was about 10 years ago there. The package at the time, PDF, PowerPoint, some additional models that might influence some work on the other side of the government customer as well. Like that looks the same with the government and when you're working with on the level of major crimes as well, of interacting with the government. But the government wants not just to track those individual procedurals for billing milestones or for tracking the work. They like to be more involved. So they want to be able to understand when a change might happen so they can understand how it's going to impact when they can field the hardware and get the hardware to the battlefield sooner, especially on the defense side, right? So how can you have that integrated acquisitions process where your customer is the external stakeholder? They're engaging with you in a way that isn't just here are the requirements. The requirements are no longer prescriptive and incredibly detailed and a very long list of everything you need to meet, but instead they lean more towards like a larger strategic level requirements and then the things you need to map to in a regulatory aspect as well. And you can just have the computer support that, bring in the master requirements and then map them against the things you care about. So it ends up being more of a conversation, and it's going to take a little while to get that if your customer is the government, but they're pushing really hard to get there. And I'm really excited about what we've been doing even with those customers to try and push the needle there, that I'm super optimistic in that space that we'll start to see those changes sooner rather than later.
Yeah. And do you guys have plans to integrate AI and LLMs into your software platform, or is that kind of a third rail given these, the high oversight and government needs?
I really love that question in particular because I mean AI is the buzzword, but machine learning is when it actually finds a use, right? So we've had machine learning in the platform since the very beginning, right? Being able to extract the engineering values inside a requirement, right? Because at the core, you have people engaging with the platform as a requirements management tool, and you care about getting the engineering values into the engineering tools, right? And so there's a little bit of machine learning and data processing and data shaping that has to happen to get that out automatically. Or you just ask the user to put the value in, right? But like you'd much rather do the first, you're going to do that at a larger scale. And so there are technologies on the hood that we've had there since day one that at the time they came out would be considered artificial intelligence. But it ends up actually being a very robust and deterministic way of correctly extracting engineering data. Because again, this goes back, this is not engineering is it's a creative act in and of itself, but it's not like, as we learned before, there's no room for failure, and you need to make sure everything's in alignment. So, not to say we don't have, LLMs as a technology. They aren't on the roadmap. They're not influencing anything. I think they're going to really accelerate the adoption of AI agents in particular. But you need to be able to deploy those in a deterministic way that they can engage with the system in a way that is enumerated, and so that you can have as many bounds as possible on that. So we've developed ways of doing that interaction that we're really excited to roll out over the next year. But we're not using LLMs to generate requirements, for example. I don't think you should be reducing the number of requirements in your system, not making new ones.
And this could be for York or Gary, is that hesitancy because of AI hallucinations, or is it more protecting data and not giving it out to a third party? I mean, you would have to basically have a plugin via OpenAI to do something like that. But what is, maybe Gary, this could be a question for you. What is some hesitancies around using LLMs within the platform?
I think it's really the traceability of that information. I mean, you talk to a lot of regulatory agencies, specifically FAA and then DoD as well, as when they look at digital twins. So getting blueprints of a design, an older aircraft, and transition that to the digital world, they cannot accurately trace that information yet. So being able to, once they kind of figure out how, if somebody whoever owns that data within that model, once they can figure out the ownership piece and where they can trace it, I think they're going to be more accepting of that. But I think AI has its place. I think it's specifically in the design phase where you can, when you're wanting to throw ideas on the board and you want AI to build you something and articulate something just to get the juices flowing and produce you a model that is creative. I think it can enhance creativity without having to provide any sort of accurate data that you really want to use towards the actual design of something, if that makes sense. But just to get the creativity going, I think is a valuable tool.
Yeah, and branching off of what Gary said, the AI is capable of generating designs, but it is a human that actually goes and implements and finds its flaws, right? And a human is one who triages between the quality of the design, the schedule that they are under, and the cost of actually implementing it. And being able to make those trades is a very resource-intensive and intelligent endeavor that we haven't seen manifest in AI necessarily. Like, I would often make the comparison that an AI is particularly good at automating certain processes and being able to tease out these details between large data sets. But it's really the human that goes and says, well, is this something that's actually actionable? And so computers are really good at repeated tasks, but they may not necessarily, they're able to design the values and use the foundational equations for creating a launch vehicle. But do they know what a launch vehicle is versus a human who can conceive of it, but may not be able to do the computations as quickly? And that's really where these two groups really come together. You have this sort of synergy.
So to kind of jump in there, like an LM alone is difficult to use beyond, it's really useful as like an alternative search engine as well, given a large corpus of information. What we do is we pair the usage of an LM and other transformers against a known ontology that's been researched for decades, right? That's how you give that level of awareness and understanding for the rest of the systems involved. And so that's how you add the bumpers on there, and that's how you end up adding that level of determinism needed in order to trust the output of the system. I don't say we don't use LLMs in anywhere in the technology. That would be, you should never write off any technology. But when we do, it's offline in a way that is not in someone else's system. So the data doesn't leave your, the most precious of data that is core to your engineering system does not leave, a secure environment. And then we can also be confident in the results the LLM gives back. So,
yeah, I mean, the hallucinating issue is a real issue with LLMs, and like I think if you're going to integrate it, you can. You just have to like really not trust it and use it as or if you want to use it, maybe not through Verve, it has to be used as as Gary was saying, a creative mind that can help generate ideas that you can then cross off. Basically, it's almost like a process of elimination type tool. But it's certainly, I mean, it's certainly, I'm not an engineer, but it's, you can look 5 years in the future and there is no doubt about the rapid adoption of AI, particularly as an assistant, and as a way of leveraging it for the tools. But I think let's move on. We have about 10 minutes left. There's another question in the chat on do you guys offer your service internationally, or is it just US domestic?
Yeah, we definitely offer it internationally. I think the main difference on our end ends up being if you are choosing for us to host the platform in the cloud, it just depends on where we end up deploying it at that point. Obviously for US customers, it was an ITAR secure deployment. You just you can get started super fast on that. If you're outside the US, definitely deploy that in a enclave more favorable to that as well. So, but yeah, we've got customers both US and abroad.
Great. And what's the Verve business model? Is it licensing fees of the software, or is it kind of a one-time integration?
Yeah, it's per seat. So pricing is on the website, and then we're always happy to have a conversation depending on the unique circumstances of deployment and the customer involved. Typically, the easiest is to do cloud deployment. We offer also on premises for folks as well, but it's sold as a traditional SaaS business model.
Yeah, got it. And taking a step back, just looking at the history of hardware development and management, how has hardware development changed over the last 15, 20 years?
Oh, man. It's gotten more, I'd say more integrated, right? I mean, you have to, as hardware becomes more complex, you're starting to bridge the gap of, well, can I fix this in software? Can I fix this in hardware instead, right? Like, so you end up, thinking about systems that can respond dynamically, and then you end up seeing like, well, where's the cheapest way to implement that change? Is it actually bending metal, or is it actually implementing it on the software side? And then how do you certify and verify out the other end that was a good decision? So I think that's been really interesting. The past 20 years, we've also tried a lot of interesting things with model-based engineering. And I think it's time for that to actually start to come of age and really see its benefit. And so, I think that's why one of the things I'm most excited about there as well.
York, how about you?
I was thinking about how incredibly competent the Apollo engineers were without having any sort of modern compute by their side. And then I think about how much we've been able to advance as a society because we've had computers. And so there's some sort of gap between the ability to do those first principle calculations back in the day versus now we sort of just rely on computers to do most of that. And there's this, built-in trust that is well-deserved when it comes to leveraging software for hardware. But we also recognize that a lot of the hardware still requires some deep simulation of these really advanced physics that's going on, whether that's rockets, reactors, robots, or rovers, right? And so we see this interdisciplinary nature of hardware evolve. That isn't just, I have a very smart wrench. It's like this very incredibly complex hardware that requires having both. And so we're trying to position ourselves to meet that wave where everything becomes integrated, whether that's, the worn out IoT, fourth industrial revolution that never manifested. We recognize that data and hardware are both necessary to truly simulate the reality that we live in. And if we want to advance beyond the planet, we have to go in that direction.
So do you think that is the kind of the next catalyst for particularly in the space industry, for innovation in the space industry? Because I mean we've seen a lot of innovation in the last 15, 20 years. And maybe less so the 20 years before that, but clearly there's a lot of momentum and a lot of interesting businesses and innovations happening right now. So do you see that as the catalyst, as kind of leveraging both the software tools plus the human mind?
Yeah, definitely. Especially when it comes to space exploration, there isn't necessarily this clear distinction between whether robots are going to replace humans when it comes to that particular industry. It's really just the combination of the two, right? There might be situations where it makes more sense to have robots, and then there might be more delicate operations that require a type of intuition that only humans have. And if we're able to better understand our own intuitions, perhaps we can model that better in robots, which then allows us to then help us develop our own intuitions. And it just keeps building up and up. Yeah, but definitely with space exploration, there's a strong need for both, and we're not at the point where we can just deploy a fleet of robots. But that could be one of the holy grails of autonomous systems.
Yeah, for sure. And we have maybe last couple comments here. If you have any Q&As or questions for the last couple of minutes, we can put it in the chat. Maybe Steve, can you provide your email real quick before the last question? For the audience, if you want to have any questions, you can take offline.
Yeah, love to. Just steve@prewitt.com. Love to talk with anyone. And yeah, just let me know. Happy to chat with you directly, and even would love a chance to set up and show the software and get you guys on the platform. So.
And we're also going to be in El Segundo for a happy hour as well, if you would like to meet in person and talk with the team.
Nice. You guys are all in LA?
Yeah,
we are. Yeah.
Nice. All right, Gary. Similar question to York, but just curious on your thoughts on kind of the future of engineering. And there's been a lot of change over the last 15, 20 years, and what are your thoughts on what the next 20 years are going to look like?
I think you still need to see that change in that rapid prototyping, agile engineering in the aviation space, right? Like SpaceX really kicked that off for commercial space. But if you look back in history in the 1950s, the 1960s, the amount of prototypes that we could produce from the aviation side, I mean, was pretty astronomical. And then you look at the 1970s, 80s, and 90s, I mean, hardware engineering, specifically in aerospace, was extremely slow, and it almost stopped. And you look at the amount of defense primes went from 30 to 40 to about 5 during that time period. So we're getting better with the aerospace startups, companies like Anduril and a few others in the aerospace side, but we need more of that rapid innovation for aerospace. And now, I mean, you're seeing the issues that are bubbling up with Boeing. Like there needs to be change identified. And I get like we shouldn't change the process. We should just change how fast we're doing it. So you can use these tools to make the process faster. We still want to make it safe because there's humans, especially in manned flight, there's humans involved, but we want to make it faster. And these tools allow you to do that without sacrificing any of the safety and risk factors.
Yeah. Every prototype you learn all your mistakes. That's the point of the prototypes. But great. This has been awesome. Appreciate the three of you guys joining today. Thank you to everyone for attending. This will be on YouTube if you want to replay it. But thank you all. Appreciate it. And we'll sign off here.
Thanks, Jack.
Thanks so much, Jack.